This is a training module on the linear technology LTC295x push-button on-off controllers. Welcome to the training module on the linear technology LTC295x push-button on-off controllers. This module will provide an introduction to the push-button controller family and help you get familiarized with the unique features and benefits of the LTC295x family. Handheld designers often grapple with ways to debounce and control push-button devices. Traditional debounce designs use discrete logic, flip-flops, resistors, and capacitors. Other designs include an onboard microprocessor and discrete comparators, which continuously consume battery power. For high-voltage multi-cell battery applications, a high-voltage LDO is needed to drive the low-voltage devices. All this extra circuitry not only increases required board space and design complexity, but also drains the battery when the handheld device is turned off. Push-button controllers enable control for DC-DC converters, processor interrupt logic, and adjustable on-off timers. They easily solve the inherent bounce problem associated with all mechanical contacts, while also enabling power supply converters and releasing a processor once the supply is fully powered up. These parts offer wide supply voltage range, small size, low quiescent current, and ease of design when compared to discrete solutions. The LTC295x family of push-button controllers incorporates the flexible timing needed to debounce the push-button input during system power on and system power off. The wide input voltage range, 2.7 volts to 26.4 volts, is designed to operate from single-cell to multi-cell battery stacks, thus eliminating the need for an LDO. The parts set of features allow the system designer to turn off system power to all circuits except the LTC2950, whose very low quiescent current is an insignificant drain on the battery. These are just some of the applications that commonly take advantage of push-button functionality. Push-button controllers find their way into many portable electronics to implement power on/off functions, as well as secondary functions like a power-saving mode. The LTC push-button controllers feature wide supply voltage range, small size, low quiescent current, and ease of design when compared to discrete solutions. The push-button inputs provide plus or minus 10 kV human model body ESD protection. An active high enable output allows the DC-to-DC converter control, or an active low enable output can be used for circuit breaker control. When looking at the LTC2950 family, the supply voltages and supply currents are very similar. Therefore, choose a part from this family by focusing on the unique timing features and additional functionality that each part offers. Focusing now on the on-off timer columns, these values show how long a push button must be pressed before the enable output is asserted or deasserted. The fifth column, the kill timer, describes how long the system's microprocessor is given before the push-button controller automatically releases the enable output. As you can see, certain timers are fixed or adjustable depending on the part. The LTC2950 and LTC2951 offer basic push-button functionality in tiny 3mm by 2mm DFN and SOT-23 packages. The LTC2952 offers a push-button, ideal diode power paths, and system monitoring functionality. The LTC2953 offers a push-button, system monitoring, under-voltage lockout, and microprocessor interrupt functionality. Lastly, the LTC2954 offers the push-button function with a microprocessor interrupt. The LTC2950 and LTC2951 are micro-power, wide input voltage range, push-button on-off controllers. These parts contain a push-button input with independently programmable on and off debounce times that control the toggling of an open drain enable output. The parts also contain a simple microprocessor interface to allow the proper system housekeeping prior to power down. Under system fault conditions, an internal kill timer ensures proper power down. The LTC295x is a power management device that features three main functions: push-button on/off control of system power, ideal diode power path control, and system monitoring. The LTC295x's push-button input, which provides on-off control of system power, has independently adjustable on and off debounce times. A simple microprocessor interface involving an interrupt signal allows the proper system housekeeping prior to power down. The ideal diode power paths provide automatic low-loss switchover between two DC sources by regulating two external P-channel MOSFETs to have a small 20 millivolt forward drop. High reliability systems may utilize the LTC295x's monitoring features to ensure system integrity. These features include power rail, voltage monitoring, and microprocessor watchdog. The LTC2953 is a push-button on-off controller that manages system power via push-button interface. An enable output toggle system power with an interrupt output provides debounced push-button status. The interrupt output can be used in menu-driven applications to request a system power down. The LTC2953 also features input and output power supply monitors. An uncommitted power fail comparator provides real-time input monitor information, while a deglitched undervoltage lockout comparator gracefully initiates a system power down. The undervoltage lockout comparator prevents the system from powering from a low power supply. The adjustable supply monitor input is compared against an accurate internal 0.5 volt reference. The reset output remains low until the supply monitor input has been in compliance for 200 milliseconds. The LTC2954 is a push-button on-off controller that manages system power via a push-button interface. An enable output toggles system power while an interrupt output provides debounced push-button status. The interrupt output can be used in menu-driven applications to request a system power down. This is different from the LTC2950 functionality, which forces a power down regardless of the application. This is useful in the case where a processor locks up and a hardware reset power down is needed. A power kill input to the LTC2954 allows a microprocessor or system to reset the enabled output, effectively powering down the system. Independently adjustable on and off timers allow dependable push-button control of the enable output and resistance to accidental toggling of the system power. Here is a comparison between the on timings in the LTC2950 family. The first column, turn on debounce time, represents the minimum length of time the push button must be held low before the enable goes high and turns on the system's DC to DC converter. The LTC2951 and LTC2953 have fixed times, while the rest of the family has the option to use an external capacitor in order to extend the time beyond the default setting. The second column, System OK response time, or the blanking time, represents the maximum amount of time given to the system to power up. Once enable is asserted, the push button and kill input from the microprocessor is ignored. However, if kill is not brought high during this time window, the enabled output is released, causing a forced system shutdown. Here is the off-time comparison. The first column, interrupt debounce time, represents the minimum length of time the push button must be held low before an interrupt is sent to the system's microprocessor to signal shutdown procedures. The LTC2950 and LTC2951 have the option to adjust this time using an external capacitor, while the rest of the family have fixed typical values. The LTC295x54 have a fail-safe feature in case the microprocessor fails to respond with a kill signal. The second column, turn-off debounce time, represents the minimum length of time the push button must be held low to force a system shutdown by pulling enable low, regardless of the interrupt state. This time can be adjusted by using an external capacitor. The LTC2950/51 and 52 also have a fail-safe feature in case the microprocessor fails to respond with a kill signal. The third column, automatic shutdown after interrupt, represents the exact amount of time given to the system before a system shutdown is forced by pulling enable low after a valid interrupt has been generated. This time can be adjusted on the LTC2951 and LTC2952 by using an external capacitor, while the LTC2950 has a fixed 1024 milliseconds. When a user turns on a handheld device, the enable output pin of the device enables a DC to DC converter. The output of the converter can then power a microcontroller, which in turn drives the kill pin. If there's a system fault, a shorted DC to DC output, for example, that prevents the microcontroller from driving the kill input high within 512 milliseconds, the LTC2950 automatically releases its enable output. This in turn shuts off the converter and prevents the handheld device from turning on. Figure 4 depicts an aborted power-on sequence. It may happen that a portable device, like a pad or laptop, has not responded to any input. Users try to restart the device by pressing the on-off button, and nothing happens. In frustration, users resort to unplugging the device and removing any batteries to shut it down. The unresponsive push button is probably the result of an on-off push button that was debounced by an unresponsive microcontroller. The LTC2950X family eliminates this common fault. It always responds to the push button in some way. It does this by initiating a power down sequence in response to the user pressing the push button, by asserting interrupt low and starting an internal timer. This event alerts the microcontroller of the impeding power down. If the kill pin remains high, the microcontroller not responding, at the end of the timeout period, the LTC295X family automatically releases its enable pin, thus shutting off the system power.